look at multiplying polynomials. So one thing I want to make sure we know is clear is multiplying, because it is a stronger power, it is going to affect more within a polynomial. So when we are multiplying, it does affect the coefficients. So when we're working with them, we're going to see that change, but we're also going to see the exponents change. So we're going to start off by just multiplying one polynomial by another polynomial. So how to multiply two terms together, a one by one. So the rule is that when we multiply polynomials, what we first do is we multiply the coefficients. So the coefficients are going to change just like when we were adding polynomials, and when we multiply, we just end up multiplying the coefficients. So it makes sense. But we're also going to end up changing the exponents. So when we change the exponents, we end up adding them together. So like I said, multiplying polynomials, multiplication is stronger, so it's not just going to change the coefficient, it also is going to affect the exponent. So for example, the most basics, we have 5x times 5x squared. One thing we want to remember is that 5x is technically to the first. So we multiply the coefficients, right? So 5 times 3 is 15, but we're going to add the exponents. So 1 plus 2 makes 3. Another way we can see it written is with this little times symbol. Sometimes it is just a dot. We'll see it written like that as well. So multiply the coefficients. 4 times 2 is 8. Add the exponents. 2 plus 3 is 5. So go ahead and try these two on your own. Pause it right here, try on your own, and then restart. I'll go over both of these. Okay, 12 times 3, multiply the coefficients. That is 36. Now again, this is raised to the first, so 3 plus 1 is going to make this now n to the fourth. So multiply the coefficients, add the exponents. Here we have 5 times 6, so that gives me a 30, and then add the exponents. 3 plus 4 is 7. So these are the most basic forms of multiplication we'll see, a one by one. But now we are going to multiply something bigger, right? We're not just going to be stuck with a one by one. We're going to see larger polynomials. So the first thing we're going to look at is multiplying a one polynomial by 2. So when we do this, it's going to look very similar to distribution, which you've already learned in middle school. When we begin multiplying polynomials, the goal is to make sure that every term in one polynomial is multiplied to every term in the other. So everything gets multiplied. So in this case, since we have this one polynomial and we need to multiply it to everything, that is just going to look like distribution. So to do this, we distribute from the monomial to the other monomial or polynomial. So distribute the one to the other. So this is where we can use our arrows. We've done this a bunch of times to make sure we show all the pathways. So here we're going to multiply 3v times v. So multiply the coefficients. Now if you don't remember, this is a 1 out in front, so it's just 3 times 1. That gives me 3. And then add the exponents. I have a 1 and another 1, so 1 plus 1 is going to give me 2. Now I have to multiply to the next term. So I have a positive 3 times negative 4. So that makes negative 12. And then adding the exponents. Remember, a constant right here, this has an exponential power of 0. So like this is the same thing as 1 plus 0, which is just 1. So it's going to stay the same since there's nothing here to change that variable. So I'll do another one with you guys. Negative 4n squared, that needs to be multiplied to every single term in the other polynomial. So we draw our pathways and we start at the beginning. Negative 4 times negative 3 is going to be a positive 12. And then we add the exponents. 2 plus 2 gives me 4. Distribute to the next one. Negative 4 times positive 4. That is a negative 16n to the 2 plus 1. Don't forget the 1 there. So to the third. And then negative 4 times negative 8, that's going to turn positive, so we get a positive 32. And so remember, there's no variable here. It's going to stay the same, n to the second. So go ahead and try this one on your own. Go ahead and pause the video. Now, you'll notice that this doesn't have a variable with it, so remember that just means exponent is 0. So pause and try this one. Okay, distribute. So negative 4 times 2, that's going to give me a negative 8. N to the first, that doesn't change, so n to the first. Negative 4 times 7 is a negative 28, and nothing will change because there's no variables. So we are going to leave this one for class to kick off our class tomorrow, so leave that one blank. Now, where things can get crazy is distribution of something larger. So when we do a binomial times a binomial, so that looks like this right here, 2 by 2. When we begin multiplying polynomials, larger ones, we have two strategies. We can still stay with distribution, which I'm going to show you first, but we also have something called box method. And box method is more visual, so if you're a visual learner, this might be the method you like the best. But in algebra, we try and stick to distribution because it stays more linear. It looks more math-based, okay? So we're going to do both. So we'll start with distribution, carrying on from the distribution up here. So in order to distribute, first we are going to break apart the first polynomial into the two terms that we have. So I'm going to go ahead and start with this example. We need to distribute both of these terms to the second parentheses, right? We need to make sure everything gets multiplied by everything. So I'm going to break these apart and treat it like two different things, a negative 5b and a positive 2. And what I'm going to do is I will then multiply each term in the second polynomial. So in order to do that, in order to multiply this to each term in the second polynomial, I'm going to write the second polynomial behind each of those two terms that I broke up. So this is going to become negative 5b times the 7b minus 8 and a positive 2 times the 7b minus 8. So that's going to have everything be multiplied together. So the first times the second, the next one times the second polynomial. So we're going to go ahead and do that, and then I'll talk about simplifying at the end. So what this does is it breaks it into two easier distributions. So I start with the first one, negative 5 times 7. That's a negative 35b to the second, so remember 1 plus 1. Negative 5 times negative 8 is a positive 40b to the first. Then I'm going to multiply these together. 2 times 7 is just 14b. And what I'm going to do is actually connect these together because this is all one problem. So if this ended up being a positive 14, I'm going to write plus 14b. So positive means plus. And then 2 times negative 8, negative 16. Now, what this does is it creates one large polynomial, right? And one way you can make sure that you have all the right terms, this is technically 2 times 2, right? 2 terms times 2 terms. What does that equal? 4 terms. And what do we have here? 4 terms. So that's kind of how we know we did it right. We made sure we had all the combinations. Now, here's the thing though. When we do all this distribution, because we have so many terms, every now and then we'll end up getting like terms. So we want to make sure that our final answer is in standard form. And we have simplified as much as we can. Now, in math, simplifying means combining like terms at the end. So if you want to put combine like terms in parentheses to help out, we want to make sure everything's combined. So if you look here, this goes back to our addition. B to the first, B to the first, we're going to add those. Now remember, the rule for adding is you only change the coefficient. So 40 plus 14, that is 54b. And it's going to stay to the first, right? Because there's no change in exponents when we add. They're both to the first. That's why we add them. So we don't want to change them. And then we just bring everything down. Okay, another example. Okay, it's just going to take some practice to get used to it. So I have a 2 by 2. So as a reminder, since this is 2 times 2, I'm going to have 4 terms when I end up multiplying. So in order to get those 4 terms, I'm going to break this apart so that I can see the multiplication more easily. 3x needs to be multiplied to the 4x minus 6, but the 6 also needs to be distributed or multiplied to the 4x minus 6. So I break it apart to do that more easily. Now I distribute. 3 times 4 is 12. X to the first and x to the first makes x to the second. 3 times negative 6 is negative 18. X stays the same. Then I distribute in the next one. 6 times 4 is going to be 24, and x stays the same. Now remember, because this is positive, we're going to put a plus, right? This is all one item still. And then 6 times negative 6 is a negative 36. Now I look for like terms and I see that I have them right here. So negative 18, positive 24. So I need to find the difference of that. This is negative, this is positive. So that is going to be a change of 6, so 6x. And everything else comes down because it didn't change. So it's positive 6, so plus 6x. Okay. One more that I'll do with you as an example because these are a little hard, and then you'll try one on your own. Now, this is where things get a little tricky, is we have to remember what squared means in math. So squared means there are 2 of them. So I have 2 of these being multiplied. That's how many I have. I have 2 of them. So what we can do to make this a little bit easier for ourselves, if squared means times itself, right, there's 2 of them, this could also be written as 4x plus 1 times 4x plus 1, right, times itself. So what I'm going to do, I always rewrite the squared twice, and then this looks exactly like our other problems. So I'm going to break apart 4x and 1, and I'm going to multiply it to the parentheses behind it. So I'm going to fill in 4x plus 1 behind each of these. I distribute the first, so 4 times 4 is 16, x to the second, right, because 1 plus 1. 4 times 1 is 4, so this is just 4x. Then I distribute the next one. 1 times 4 is 4, so 4x. 1 times 1 is 1. I notice that I have like terms in the middle, so I have 16x squared plus 8x plus 1, and that's our answer. So go ahead and try number 5 on your own. Go ahead and pause it, and then we'll go over it. Okay, so first thing is I'm going to break apart. I have negative 8n, negative 1. And I'm going to multiply each of these to the 2n squared plus 7. So I'm going to fill that in behind each one of these. Nothing changes even if our terms look a little bit bigger, right? Nothing will change. This is just sticking behind each of the first terms. Now I'm going to distribute. Negative 8 and 2 is negative 16 into the third, because 1 plus 2 is 3. Negative 8 times 7 is a negative 56n. Now I do the next one. Negative 1 times 2, negative 2n squared. Negative 1 times 7, negative 7. Now, this was a little bit different. If I look, I do not have like terms at all in here. So I'm not going to be combining anything. But one thing we want to remember is we need to put this in standard form. Is this in standard form? The answer is no, because that squared is behind a first. So I just need to rewrite this into standard form, and I'm done. So we are going to save these 2 for class to go over. Now, if that was a little difficult, it may be because you're a more visual learner, which is where box method can also help. So we're still multiplying. We're going to do the exact same thing as we did, but we just have a visual approach to it instead of breaking apart and looking more linear here. So in box method, the first thing we're going to do is we are going to be taking a visual approach. And we need to do this, we're going to end up creating a box, right? That's why it's called box method. But to figure out what kind of box we're going to do, we need to figure out how many terms we're working with. So we have a 2-term times a 2-term. So we figured out how many terms we have, a 2 by 2, which means we are going to be making a 2 by 2 box. Once we know how many terms, we draw a box with the same number of columns and rows that we counted. So 2 columns, 2 rows. So 2 columns, 2 rows. Now, we are going to label the columns and the rows with one of the polynomials. So it doesn't matter which one goes where, as long as you keep the polynomial together. So this is my first polynomial. I'm going to make it my columns. So each term is going to get its own column. So 5v, positive v squared. The other one is now going to be the rows, 3v and 4. Now, this may be where some people start getting confused of like, wait, what are we doing? Why are we doing this? The reason why we're doing this is we're going to show the different pathways of multiplication that we did here. And this is just an organization method. Don't think that there's like some crazy math reason we're doing this. We're just organizing the different multiplications that we're going to be doing. So it's just all this is organizing our info. So what we do then is we will multiply the column and row that make up each empty box. So for example, this empty box is made up of this column, this row. So I'm going to multiply these two numbers together. Same rules, 5 times 3, that's going to give me 15. V to the first, V to the first, add them together, I get V squared. This box is made up of this column and row here. So remember, there's a 1 in front, so 3 times 1 is 3. And then add the exponents. 1 plus 2 is V to the third. Here, 5 times 4 is 20. And the V stays the same, nothing changes. 1 times 4 is 4. V squared stays the same, nothing changes. So all we did here, all the box did was visually separated stuff to show the different terms we would make, right? It's the same thing, but a little bit more visually appealing. So what we need to do now, though, is we are going to pull all of these terms out and put it into standard form and combine like terms, just like before. We need to simplify it. So one thing we can do is when we're pulling this out, we can write it into standard form on its way out. So the largest exponent is to the third, so 3v cubed. Then I have a positive 15v, so remember positive means plus. I have a positive 4, so plus 4v squared. Positive 20, so plus 20v to the first. And what you'll see is what we have right here is like this line where we did all our combinations of multiplying. We have our 4 terms, combinations of multiplying, 4 terms. We look to combine if there's anything, and we should see that we have like terms here. So 3v cubed comes down. And remember, to combine like terms, we just add the coefficients. So 15 plus 4 is 19. So 19v squared. We do not change this. That is not part of adding. And then the 20v comes down. And that's it. That's our answer. Box method, more visual. So I'll do another one with you guys, 2 by 2. So 2 by 2 box. Doesn't matter which one is the columns and rows as long as it stays together. So this whole thing, I'm going to make my column. So negative 8x, negative 3. Positive 4x, oops, and positive 6. So now I multiply down the paths. So 4 times negative 8, that's a negative, not negative 2, negative 32. And that's going to be x to the second, because remember, there are 1s there, and we have to add them. 4 times negative 3 is negative 12, and it's going to stay x. Negative 8 and 6 is negative 48. It stays as x. 6 times negative 3, negative 18. And again, same thing as this. It's just a more visual way to show the different combinations of multiplying. So we still need to pull this out and put it into standard form. So if I look, this is my largest exponent. So I'm going to pull that out first, a negative 32x squared. These are both to the first, so it doesn't matter which one comes out. So I'm going to pull out this minus 12x, minus 48x, and then minus 18. And what we see is that we have like terms here. These are both to the first. Negative 12, negative 48. That's a bigger negative, so this becomes negative 60x to the first. It stays as the first. And then everything else will come down because it's not changing. All right, I'm going to have you guys try this one on your own. Now remember, I'm going to help you start it and then try it on your own. Squared means times itself. There's 2 of them. So this is the same thing as negative 6v minus 5 times a negative 6v minus 5. Same thing, times itself. So this looks exactly like this now. So go ahead, pause, draw your box, multiply, and then check your work. Okay. 2 by 2 box. negative 6v minus 5. And then this one just happens to be the same because it was squared, right? So times itself, that's what's happening here. Multiply into the boxes, negative 6 and negative 6 is positive 36v squared. Negative 6 times negative 5, positive 30v. Same thing here is a positive 30v, and then positive 25. We pull out into standard form, so 36v squared plus 30v plus another 30v plus 25. And we see that we have like terms here, so we combine them for 60v. Everything else comes down, and we are done. So these two we will save for in class.